Partial fraction decomposition, part 2, quadratic factors. Welcome to Mark's Math Methods. Let's jump right in. Example 1, convert 3x squared minus 5x plus 24 over x cubed minus 2x squared plus 9x minus 18 into the sum of some factors. First, we need to factor the denominator. And we end up with x squared plus 9 times x minus 2 when we factor the denominator. So we used those factors as our denominators in our new fractions. So we'll have something over x squared plus 9 and something over x minus 2. Let's put in some placeholders for those unknown numerators. A over x squared plus 9 and b over x minus 2. No, not quite. Can't do it that way. The numerator needs to be 1 degree less than its denominator. So the x squared plus 9 is quadratic, and therefore its numerator must be linear. So I'll write ax plus b. X minus 2 is linear, so we just need a constant over it. And we'll use c over x minus 2. Now we need to find the values of those placeholders, just like before. So the first thing we need to do is clear the fractions. So we're going to take the whole equation and we're going to multiply it by the x squared plus 9 times x minus 2 over 1. Multiplying on the left side, everything cancels, so we're just left with 3x squared minus 5x plus 24. On the right, the first fraction, the x squared plus 9 cancels, so we have ax plus b times x minus 2. And the last fraction, the x squared plus 9 times c is left because the x minus 2 canceled. Now the magic. Let's let x equal 2. That takes out the a and the b, leaving only the c. So we put 2 in for all the x's. So on the left we get 3 times 2 squared minus 5 times 2 plus 24. And on the right is c times 2 squared plus 9. And we end up with 26 equals 13c. Divide both sides by the 13 and c equals 2. There are no more values that can eliminate terms. Because nothing I can put in for x to make x squared plus 9 turn into a 0. Of real values. I could use imaginary, but I don't want to. So let's just pick a number. Pick 0 because it's easy. It eliminates a lot of things. So on the left is 3 times 0 squared minus 5 times 0 plus 24. And on the right is a times 0 plus b times 0 minus 2 plus c times 0 squared plus 9. Leaves us 24 equals b times negative 2 because the a disappeared, plus c times 9, or 24 is negative 2b plus 9c. Well, we have c from the first one, so if we plug that in, we now get 24 equals negative 2b plus 9 times 2, or 6 is negative 2b, so b is negative 3. So let's let x equal 1. Another easy one. So plugging in 1, 3 times 1 squared minus 5 times 1 plus 24 equals a times 1 plus b times 1 minus 2 plus c times 1 squared plus 9. So 3 minus 5 plus 24 on the left. A plus b times negative 1 plus c times 10. So we end up with 22 equals negative 1a minus b plus 10. Since we know b and c, we can plug them in. So we get 22 equals negative a minus negative 3 plus 2 times 10. 22 equals negative a plus 3 plus 20. And we end up with a equals 1. And we subtract the 23 over. So now we have all three of them. Is there a different way to find those values for a, b, and c? Let's clear the fraction like we did before. But instead of choosing a value for x to eliminate different terms, let's just multiply the entire right side out. So on the right side, ax plus b times x minus 2 would give us the ax squared minus 2ax plus bx minus 2b. And then multiplying c times the x squared plus 9 would give us cx squared plus 9c. Now let's just look at the x squared terms, because they have to be equal left side and right side. So we end up with 3x squared equals ax squared plus cx squared. Well, they all have x squares. Let's just look at the coefficients. So 3 has to equal a plus c. Okay. Now let's look at the x terms, or linear terms. On the left-hand side, we've got negative 5x. And on the right side, we've got negative 2ax plus bx. Getting rid of the x's gives us negative 5 equals negative 2a plus b. And now we'll look at the constant terms. So the left side is 24. The right side is negative 2b plus 9c. I've got 3 unknowns, a, b, and c, 3 equations. So we can use matrices. So if we set it up such that the first row is x squared, second row would be x, third row would be constant, and then the first column is the a's, second column is the b's, third column is the c's, and the fourth column would be all the solution parts on the right, all the parts in red. So for the x squared, we've got 1a plus 1c equals 3. So 1, 0, 1, 3. For the linear, we've got negative 2a plus 1b equals negative 5. So negative 2, 1, 0, and negative 5. The constants, negative 2b plus 9c equals 24. So 0, negative 2, 9, and 24. Now if we use RREF, it yields, oh, look at that main diagonal. It's all ones. That means we have a solution. So the x squared, So A is 1, B is -3, and C is 2. That was the same thing we had before. Here's another problem. Example 2. Let's convert x squared plus 2x minus 2 over x cubed minus 8 into the sum of some factors. Factor the denominator. We've got a difference of 2 cubes, so we end up with x minus 2 times x squared plus 2x plus 4. Those become our two denominators. We need our placeholders. So a over x minus 2, and then a linear bx plus c over x squared plus 2x plus 4. Clear the fraction. On the left, we just have x squared plus 2x minus 2. On the right, we get a times x squared plus 2x plus 4, and then we get bx plus c times the x minus 2. Let's use the same technique we did the second time. Let's multiply everything out. So on the left, we've got x squared plus 2x minus 2. On the right, ax squared plus 2ax plus 4a plus bx squared minus 2bx plus c minus 2c. X squared terms. X squared equals ax squared plus bx squared, or 1 equals a plus b. X terms. 2x on the left and on the right is 2ax minus 2bx plus c on the right, or 2 equals 2a minus 2b plus c, and our constant terms, -2 on the left equals 4a minus 2c on the right. So these were our three equations. The x squared was 1 equals a plus b. The x was 2 equals 2a minus 2b plus c, and this constant was -2 equals 4a minus 2c. Three equations, three unknowns. Set it up as a matrix. 1, 1, 0, 1, 2, -2, 1, and 2, 4, 0, -2, and 2. Top row is quadratic, middle is linear, bottom is constant, first column is A, second column is B, third column C, and last column is the solutions. Use RREF and it yields 1, 0, 0, 0.5, 0, 1, 0, 0.5, 0, 0, 1, 2. Get that main diagonal of all ones, so we're good. So there we have it. 1/2 over x minus 2 plus 1/2 x plus 2 over x squared plus 2x plus 4. I hope the presentation was helpful. Thumbs up, subscribe, comment. And if you have any problem types you'd like me to demonstrate, there's my address.